Okay, so my name's Kepner. This is lab 3. I'm gonna go pretty fast because we have 5 minutes and I want to go fast. So introduction, purpose was to investigate circuit fundamentals, loops, nodes, parallel resistors, whatever, series stuff as well. See firsthand how changes resistance, direction of connections affect voltage, and can observe how capacitors charge and discharge. As a result, in the first part of the experiment, we saw how the loop rule worked and how when potential differences around a circuit are present, they will sum to zero. With EMF with the battery, of course. And then when current is in a circuit, it's constant everywhere. Second part of the experiment, we saw how capacitors charge and discharge through different resistance bulbs. And we kind of noticed that the bulb increased in brightness and decreased in brightness exponentially, which means that the capacitors charge and discharge exponentially as well. And then lower resistance charges slower but discharges faster, and then the higher is the opposite. So I'll show you in a minute table about that. Main physics principles, loop rule, node rule, equations are present. You can see them, resistance, current, and voltage. Potential difference, you can read. Experimental procedure. So we connected basically circuits with two batteries and resistors and just set them up to measure voltage and amperage with ammeters and multimeters. And then we kind of changed circuits around and did it again. Then the second part, we connected a battery to resistors and, or sorry, not resistors, bulbs and capacitors, and let them charge and discharge. And so right down here, you can see the time of that. The pattern described in the previous slide is present here. It kind of flip-flops crosswise. It's a bit strange. So circuit calculation process. Over here on the left in these blue numbers are the ideal resistance values. So to find the resistance for this, we divide the potential difference by the current, because usually V equals IR, but you can just solve for that. We experimentally measure the current to be 23.7 milliamps, and so in this case, these voltages are all experimentally measured as well. In this case, these were not ideal. The wire is pretty close, but we'd hope for that to be true. And meter was really off, and then these two values are also very off. System is a circuit surrounding the table of measurement instruments. Initial conditions, two 1.5 volt batteries, 47 ohms, 100 ohms, bulbs, 10 ohms, 20 ohms. We get into more bulbs, capacitor stuff later. No code this week. Super happy about that. Now, what if questions? What if we charge a capacitor with no resistor? Well, the capacitor would still charge exponentially as time goes on, but it would charge faster. How quickly? Well, it'd be faster. I mean, that's just how it works. If there's no resistance, then the charge can flow more freely. Would the prediction happen in real life? Yes, but the numbers would be slightly different. So there's resistance in the wires and connections. So we can kind of see that with these calculations here, how these numbers are different from the real ones, where the resistance is present in the wire when you, and ideally you would kind of just ignore that. That's what we're doing in our, that's what we're doing in our calculations as well. That's why the measured time will be different, mainly because even when there is no resistor present, there is still resistance in the wires and connections. So it's not really that ideal. Possible error. Similarities between the model and real life. I mean, there was no real ideal model this time with no code, but ideally there would be no resistance in wires and connections. Also, charging and discharging had to occur, so that's regardless of it's real life or in your imagination. Differences, like I just said, we assumed no resistance, and then timing of the charging was not perfect, so that kind of leads into error, where human error was present in measuring the voltage and amperage, and then calibration multimeters could have been off. That's just kind of like, that's probably not true, but it's possible. Inconsistencies in the wire material, and then human timing error, and so those numbers that I had in the table before may be slightly off because we're human and we make mistakes in timing. Anyway, that's lab. Thank you.